Hello, today we're going to talk about nomenclature for binary ionic compounds. Today we're going to learn how to write the name of a compound. So what you're going to do is watch this video and complete the guided notes section for nomenclature of ionic compounds. Afterwards, you're going to complete the worksheet naming simple ionic bonds. That worksheet is due tomorrow at 8 a.m. So the first thing we're going to do is a do now. Write the following chemical formulas for the ionic compound formed by the given elements. Remember to crisscross your charges. Don't move on until you've finished completing the formulas. And here we go. So sodium has a +1 charge, fluorine has a -1 charge. So when you crisscross your charges, you have one of each. So NaF is the correct formula. Calcium has a +2 charge, it's in group 2. Sulfur is group 16 and has a -2 charge. If you're looking at your periodic table, when you crisscross your charges and reduce, you get a 1-to-1 ratio, 1 calcium for every sulfur. Barium has a +2 charge, it's in group 2. Phosphorus is group 15 and has a -3 charge, so when you crisscross your charges, you get a 3-to-2 ratio, 3 bariums for every 2 phosphorus. You can't reduce a 3-to-2 ratio any lower, so that's your formula. Cesium has a +1 charge, oxygen has a -2 charge. When you crisscross your charges, you get 2 cesium for every 1 oxygen as your formula. Alright, so nomenclature of chemicals. Nomenclature is a fancy way of saying a system for naming compounds. The International Union of Pure and Applied Chemistry, or IUPAC, has made a standardized way of naming compounds. This means that if you go to, I don't know, Thailand, but you're American, when you're talking about chemical compounds, you're still talking about the same name and the same compound. It's a way to help avoid any confusion or accidents when ordering chemicals, using chemicals, and discussing chemicals across borders. You're going to want to recognize IUPAC, and again, anything in color is what you should be filling in your guided notes. But IUPAC, you will see questions say, name the following compound according to IUPAC rules. And it's just referring to the rules that you're learning right now. There are many common names that we use every day for compounds. For example, salt is sodium chloride. Sodium chloride being the chemical name, but we just call it table salt. Vinegar is technically called acetic acid. So there are some common names for chemicals that we'll talk about this year. So steps for naming binary ionic compounds, and I believe you're going to have to type all of this in. Pause the video if you need a second to catch up, but identify cation and anion. So again, your cation is always going to be named first. So the metal is named first, just like it comes first in your actual chemical formula, followed by the anion or your non-metal. You name the cation with its element name. You can use table S to look up the chemical name, or if you've memorized your elements, you'll already know it. And then you name the anion also using the elemental name, but you drop the ending and add IED to the ending. This IDE ending is just indicating that you are using an element bonded with something else. Again, pause the video if you need time to type down these steps. So here's our first example. We're going to write the formula for the compound made between beryllium and sulfur. So what we're going to do first is write the formula for the compound made by beryllium and sulfur. Go ahead and do that in your notes. When you're done, you should crisscross your +2 charge for beryllium, your -2 charge for sulfur, reduce, and get BeS as the formula. Now we're going to write the name for the compound made by BeS. Again, you're going to name your cation first because it always appears first in your actual formula. Metal has to go first, non-metal goes second, and that's going to be our anion. If you already know the names of these two elements, it makes life a lot easier. but if you have to look it up, you can do so. If you have to look up the name or want to check, you can come to table S. So table S, we find Be, which is beryllium, and there's the name of our cation. We don't have to change anything. That's the first thing you're going to write down. We head down, we find S, which is sulfur. Sulfur is our anion. Our anion, we're going to have to drop the ending and add IDE. So in this case, we're going to drop that UR and add IDE, meaning that the name of this compound, BES, is beryllium sulfide. Again, our cation, nothing has changed. Sulfur, we drop the UR and add IDE to the ending. Let's try another one. So write the formula for the compound made between potassium and beryllium. When you've crisscrossed your charges, this is the formula you should get. And now we're going to name it. So again, you can go to table S if you don't remember the names. So K is element 19, Te is element 52. I come down to table S. K is potassium. Again, we don't change our cation, so we're just going to write the name potassium. And then we're going to name Te, which is element 52, tellurium. We're going to drop the ending and add IDE so that we get the name potassium telluride. Let's try another one. Write the name for the compound here. Go ahead and try. And you should get rubidium for RB, nitrogen, so we're going to drop the ending, so basically the last syllable. Drop the last syllable, add IDE for the ending, and you have nitride. So now we're going to look at writing the names of ionic compounds with transition metals. So the last few examples have been for group 1, 2, and applies to group 13 cations. Now we're going to look at transition metals, so group 3 through 12. Transition metals are unique because they have more than one charge written in the top right corner on the periodic table. And that's something we're going to have to account for in the name. What I'd like you to try first is identify which of the following are actually ionic salts. So which of the following compounds are actually ionic? 3 and 4 are ionic. This is a nonmetal bonded to a nonmetal, so that's actually a covalent compound. Nonmetal, nonmetal, not ionic. Metal, nonmetal, we have ionic salt. Metal, nonmetal, ionic salt. All nonmetals, not ionic. Alright, so looking at your guided notes, you're going to have to fill in a little bit, but nomenclature for ionic compounds with varying charges. This method is for naming compounds that contain transition metals, so again, group 3 through 12, or metals that have multiple charges listed on the periodic table. They're referred to as what are called multivalent metals, meaning they can emit different charges of ion. So again, your steps are pretty similar for naming. You're going to identify the cation and anion. Write the element name of the cation. You can use table S if you need to. And write the charge of the cation as a Roman numeral. So this is the step we're adding. When you have a multivalent metal, you're going to have to write the charge it's taking as a Roman numeral. And then lastly, you're going to write the name of the element for the anion in the chart and change the ending to IDE, not the charge. So you write the element name for the anion, drop the ending, change it to IDE, just like we were just doing before. So if we take a look, this is what I'm referring to. So if you're looking at group 3 through 12, a lot of these elements have multiple charges that they can take on. They're multivalent. I'm not talking about ones like, let's see, like silver only makes a +1 charge. You don't have to use this naming system when only one charge is listed. It is for these transition metals that can take on multiple charges. You have to tell whoever is looking at the name of the compound which charge it's taking on. So Roman numerals, just a reminder, and please, again, write this down. But here are your Roman numerals, 1 through 10, I for 1, 2 for 2, 3 lines for 3. But then 4, you have the V with the I on the other side, 5 is just the V, so on and so forth. You need to know 1 through 10 in order to use them for naming in chemistry. So if you don't have these memorized, please make flashcards, do what you have to memorize them. All right, here we go. So we're going to write the name for iron and oxygen bonded together. So Fe is iron. If you don't know that, again, you can use table S. The most important part here is figuring out the charge. So essentially what you have to do is reverse crisscross the charges. So if we undo our crisscross, right, because normally we look at our charges, we crisscross in order to actually get the ratio for our chemical formula. We undo that process. We know that oxygen will have a -2 charge as the anion, and iron must have a +3 charge, which would make this iron, Roman numeral 3 for the charge, oxide. Let's try another one. So here we have a 1-to-1 ratio between copper and chlorine. Here's another way that you can figure out the charges. So if we look at chlorine, chlorine usually takes a -1 charge. So ignore the fact it has multiple charges listed. It's almost always going to take the first one listed, which is -1. That means if chlorine is a -1 charge and we're looking at copper and they're in a 1-to-1 ratio, it's going to be a +1 charge for copper. So if we have a 1-to-1, or if we undo our crisscross, we would know this is +1 and this is -1. So we have copper, the name of our cation, 1, Roman numeral as the charge, chloride, still dropping the ending of chlorine and adding IDE to the ending. Let's try it again. So chlorine pretty much always takes a -1 charge. If we reverse our crisscross, that would mean copper has a +2 charge, chlorine has a -1 charge. So this is copper, Roman numeral 2 for the +2 charge, chloride. And this is why it's important to denote which copper you're talking about, because we can have copper 1 chloride, which has a different formula, and we have copper 2 chloride, which has a different chemical formula and therefore is a different compound. So if we just called both of them copper chloride, that wouldn't tell another scientist which compound we're using. Hence why we have this naming system. Here's another one. So because these are a 2-to-2 ratio, you have -1 for chlorine usually, and a +1. You have 2 +1s for mercury, so it's mercury 1 chloride. Now this one you're going to have to use your reference table for. If we take a look at sulfur, sulfur is going to always take on pretty much a -2 charge. Iron can take on either a +2 charge or a +3 charge. In this case, because they're 1-to-1, we have sulfur with a -2 charge. Sulfur has the -2 charge. Iron is going to have a +2 charge. When you have a +2 crisscrossed with a -2 and you reduce, you get the FeS, a 1-to-1 ratio. So our charges are balanced as long as this has a +2 charge and a -2 charge, meaning that we have iron 2 sulfide. Now, if we reverse our crisscross, again we have a -2 charge for sulfur, a +3 charge for iron, and this is what iron 3 sulfide is going to look like.